Okay, so we have another tris problem, right? So it says tris, a commercially prepared molecule often used to make buffers for biochemical experiment, exists in two forms: a tris base with a molecular weight of 121.14 grams per mole, and a tris acid, and the molecular weight is 157.6 grams per mole. The extra weight is the chloride counter ion. And I wrote the definitions here on what is a counter ion. So the counter ion is an ion of opposite charge that accompanies another ion in a solution or crystal lattice to maintain overall electric neutrality. In other words, it's the other half of an ionic compound, ensuring that the total charge of the substance is zero. And then we have the pKa of the acid, which is 8.10, and we have access to both forms as powders, and it's asking us how would we make up 0.5 liters of a 20 millimolar tris buffer at the pH of 810, and we have to include all the steps. So I already wrote what is given to us, as we can see here. So we have a tris base, right? And the molecular weight is 121.14. We have a tris acid, 157.6, the pKa 810, the final volume 0.5 liters, the total buffer concentration 20 millimolar, and the desired pH is 810. And I want to point out something for you guys here. So the pKa and the pH actually have the same value, right? And that means the pKa and the pH is equal to each other, right? And I just wrote this rule, something that we can remember. So when the pKa is, when the pH is greater than the pKa, is more basic. But when the pKa is greater than the pH, it's more acidic. But when the pH is equal to the pKa, it's an equal buffer, right? And you may ask, what does this mean? So this means that the buffer must be 50% acid and 50% base. So 50% acid and 50% base. So I just want to write, in other words, let's just write it like this too. A minus equal to HA. And remember, HA is the base, A minus is the acid. I hope I'm not messing up neither. Oh, sorry guys. A minus is the base and HA is the acid. So the formula will go like this. We use the Henderson-Hasselbalch formula. pH equal pKa plus log over A minus over HA. And if, since the pH is equal to the pKa, we can just write log over A minus HA equal 0. Because if we should track A10, 8.10 minus 8.10, we're going to get 0, right? And say we solve this, we take the log to get the ratio of A minus over HA. Right, cancel that out. We put A minus over HA, and it will be 10 to the 0, and 10 to the 0 is 1. So it's 1. Right? So what we're going to do now, step 1, we know that the ratio is 1. So step 1, we're going to find the total moles, right? And I just want to point out this is millimolar, so we want it for molarity. So what we can do is we can do 20 times 10 to the negative 3 mole times the final volume, which is 0.5 liters. Let me just circle that for you. So the total buffer concentration and converted is 20 times 10 to the negative 3 moles. Molarity, I mean. Yes, molarity. Total buffer concentration right here, and the final volume is right here. And we're going to multiply that in order to find the total moles. So give me a moment. Let me put in my calculator. And the answer is going to be 0.01 mole total. Alright? And since A minus is equal to HA, we can just do 0.0 moles over 2, because it's split equally, it's split into 2. And when we divide that, we're going to get 0.005 molarity. So now we need to find out how much the sodium hydroxide creates A minus. And let me just make everything small. Excuse my handwriting. I do write a bit big. I hope it is you're able to see it. Alright, so yeah, this was step 2. No. Sorry guys, so this is step 2. I'm gonna just label it so we don't get confused. And step 3. And we need to figure out how much is NaOH. Right? So NaOH is a strong base, and it creates A minus, which just represent base. So it's gonna be HA plus OH minus reacts with A minus. So we can just sum it up as the moles of NaOH equal to the moles A minus, and that's going to be 0.0500 moles. And then for the volume, all we have to do is convert it. So it'll be 0.0500 liters, and we convert it to millimolars, which is 50.0 milliliters. not millimolars, milliliters. Sorry, guys. Right? Because NH1, wait, NaOH. Yeah. And then step 4, now we have to figure out how much buffer powder to weigh. Because yes, it's asking us how would we make up the tris buffer and include all the stuff, not just the amount to weigh out or a ratio. So we will need the total moles of buffer, which is 0.01. So let me just minimize this so we can have space. Step 4. So how much a buffer powder to weigh? And then the total will be total moles buffer, remember, is 0.01 mole, which we calculated in step 1, which is right here. And how we solve this, it will be 0.01 times the molecular weight equal grams, right? Because it's the same as before, the total buffer amount, it doesn't change. So we're gonna use, we have 2 molecular weights for the base and the tris acid, and we're gonna plug it in. So 0.01 times the molecular weight, that's the tris base. We'll just put tris base in parentheses so we can know. Equal, and then 0.01 times 157.6 tris acid. And so it's going to be 0.01 times 121 point, oops, I always mess up in the calculator, 121.14 equal 1.2114 grams. And that's going to be, now we're going to calculate the tris acid. 0.01 times 157.6 equals 1.576 grams. Right? So now we have the total mole buffer. We have the buffer powder to weigh. And this is the answer. This is how much we need, and this is the total buffer moles because it's equal to each other. And we're finished our tris buffer. Let me know if you have any questions below.